Hello everyone. So in this video again we have a very interesting question for you pertaining to time speed of boat and streams. So these questions again are taken from the previous year placement papers of various companies, be it their off-campus drives or on-campus drives, pertaining to their job aptitude test examination. So these are also previous year questions in such on that regard as well. So we'll take a look at this question. So these questions have already come across the various examinations like or various recruitment processes of companies like Google, Microsoft, Amazon, IBM, and various software other say web-based, service-based companies and product-based companies, also a few code companies as well. So we'll take a look at that as well. So a man can row 4.5 kilometer per hour in still water. It takes him twice as long to go upstream than to go downstream. Okay, so basically time in upstream is twice time in downstream. So that is what's given. What is the rate of the current? Okay, so therefore let speed of man equal to m of man equal to m equal to 4.5 and speed of stream equal to speed of stream being s. Okay, so now for upstream the time will be given by distance by speed of man plus speed of stream, and for downstream the time will be given by total distance by speed of man minus speed of stream. Okay, now we know time in downstream is actually twice, oh no, time in upstream is actually time twice the speed of downstream. Okay, this is downstream, it will be here. Upstream take twice the time as compared to downstream. Okay, so now distance is constant. So with the current situation, let's try and solve the same. Since distance is constant because they are going the same distance, we can cancel this up. So therefore we can actually write twice m plus twice s equal to m minus s. So therefore we can write as m equal to 3s. M here is 4.5, 3s. So if you sort this out, s equal to 1.5 kilometer per hour, which is the speed of or the rate of the stream. So I hope this is clear to you. The approach we have taken, simple, we have taken the concept of time equal to distance by speed in this case, and we have applied relative speed pertaining to the direction. So let's take a look at the next question. So next question we have of simple interest. So let's take a look. A sum of money amounts to rupees 9,800 for 5 years and 12,005 for after 8 years at the same rate of simple interest. Okay, the rate of simple interest per annum is, okay, so let's take a look. So for 5 years the amount is 9,800. For 8 years the amount is 12,005. So therefore for 3 years SI will be 12,005 minus 9,800, which is rupees 2205. Okay, so for 3 years this is the simple interest. Now if we talk about SI for 5 years, so SI for 5 years will be 2205. Since this is for 3 years, so divided by 3 we'll get the simple interest for 1 year and into 5. Okay, this comes out to be rupees 3675, and therefore the principal or T, which we can write, that will be 9,860 minus 3675. So the principal will be 6125. Okay, Now we already know SI is given by PRT into 100. Okay, so SI here given by 3675, principal is 6125, rate we need to find out, time is 5 years divided by 100. So if we solve the same, we'll actually find 20 5 subsequently r equal to 12%, which is our final answer. So I hope this is clear how we came about solving with the same. Simple, we use simple concepts of simple interest here. Now let's take a look at the third question. So here another question we have, it's of basically time, speed and distance. In general, let's take a look. A man starts walking at 3 p.m. He walks at a speed of 4 km per hour on level ground, at a speed of 3 km per hour uphill, speed of 6 km per hour downhill, and again a speed of 4 km per hour on level ground to reach home at 9 p.m. What is the distance he covered on the way? Okay, so basically if we talk about the trajectory of the same, this is how the person goes. Okay, so here he starts at 3 p.m. and say this is his home. He reaches at 9 p.m. So he basically travels for 6 hours. Okay, say he travels for time t1 here, time t2 here, time t3 here, and time t4 here. Okay, so here his speed is 4 km per hour, here it's 3 km per hour, again it's 6 km per hour, and here it is again 4 km per hour. So this is his speed. Now we have denoted all the times from the speed respectively. So now one thing we can note here is that the time okay, the distance with he travels in uphill, means this part, and downhill the distance will be same, because any peak will have similar distances altogether. So therefore the distance traveled uphill distance will be speed into time, so 3 into t2 will be equal to downhill distance, that is 6 into t3. So therefore 3t2 equal to 6t3, we can write that. So therefore we can write t2 equal to 2t3. Okay, t2 equal to 2t3. Now if we talk about the total time that is required, total time that is taken, that is being 6 hours, so it will simply be t1 plus t2 plus t3 plus t4, this will be 6 hours. So here t2 and t3 we already know the relation of the same, right? So t2 we can simply substitute t2 by t3, so t1 plus 2t3, so it will be t3 3t3 plus t4, sorry, t4 equal to 6. Okay, now one thing we can do is that we can assume that this particular distance and this particular distance, also the time at which they travel for this particular duration, or the total distance in this particular time, let us suppose that is equal. Okay, so let us suppose distance traveled in this duration of time is actually equal. So we can again write as basically t1 equal to t4, say they travel for equal duration of time during that point. So we can write the same as twice t1 plus 3 t3 equal to 6. Okay, say this is 1, this is 2, and we can write this one, say this is equation 3. So now this been equation 2, this been equation 3. Okay, so we can represent the same in this way. Now if we talk about total distance here, total distance will be, if I write twice t1, so 4 into twice t1 plus 4 into twice t1 plus 3t2, 3t2 plus 6t3. So this is our total distance. Okay, let this be 4. Now if we substitute 1 in 4, substituting 1 in 4, we have total distance equal to 8t1 plus 12t3. So we can write that, which can be further if we take 4 as common, so 2t1 plus 3t3. Now this value we already get from 3 is 6, so therefore this becomes 4 into 6 equal to 24. Okay, so total distance will be 24. And now if we are talking about one way, what is the distance covered on one way? So one way will be half of this, that is 12 kilometer, which is our answer. So I hope this is clear to you, the approach we have taken towards solving this particular questions in general. So kindly go through all the 3 questions here so that you can get a better idea on the approach we have taken towards covering this, and also you can get a clear sense of how we have covered all this, and kindly solve the questions on your own with the video as a reference. So that's it, we've come to the end of the video and I'm signing off. Thank you so much.